you don't know the population mean. So you use your sample mean, and you can find this in your L1. You can put it in your L1 table. Find your sample mean. We have a variance for your population. We have a variance for your sample. We have a standard deviation for your population and a standard deviation for your sample. This is where in your calculator you see SX. You see this for population, this for sample. And the last one that's not going to make too much sense right now, we have a proportion, and we have a proportion with a little hat on it called a p-hat. So we'll hit that in this section as well. Now, when you do this, you're estimating for the mean because you're making an inference about your population based on your sample. Based on my sample, I can say this about my population, because otherwise, where do I get my information about the population? Make sense? Okay. And this is good for you too, because this is what we worked on last week, or the week there. Okay. All right, these guys, you have to find your corresponding z-score for that confidence interval. Now, we refer to this as the z sub c, a confidence interval for your z-score. Remember how we talked about this last week? If your confidence interval is 80%, 8.80, 80% of your data sits in the middle. So how much is left out of 100? 20. You know which one is better is the one over there. That's better. Okay, so 20% is left. Each tail has to have the same amount. So 100 minus 80 is 20. These two have to add up to 20. Divided by 2, this gets 10%. This is the z-score you want to catch because it's always your area to the left. So look up inverse norm for 0.10. You get a negative and you get the opposite, the symmetric part, the positive. In this equation, we're only going to use the positive z-score. We need this for your margin of error formula. Your margin of error formula says, give me this value, your z-score for your confidence interval, your standard deviation divided by the square root of n. So we need that for your margin of error formula. 75 works the same way. Take 100, God bless you. Subtract 75, divided by 2. Each one is 12.5%. Move your decimal. All right. Are we comfortable with this? I don't know which ones I gave you. Out of these, I picked a few of them. 5 and 6? I guess this is 6 down here. So, again, 85, take it off of 100. Your curve is symmetric. Then divide it in half. When you get 7.5, or I guess if you're going to do this and divide this out and get 7.5, remember this is based on a percent. Remember, you still have to put this in decimal form. So you got to move your decimal 2 places. Can everybody do that? That's important that you can find this. Normally, like your chart on your notes have the normal ones, the 90, the 95, I think it has a 98 or a 99. It has your normal ones that we normally use. But every once in a while, you're asked to find a different one. Okay? What did I skip? 9 and 11. 9 and 11. Oops, sorry about that. 9 and 11 were nice because they gave you a graph. And my copy doesn't show up that great. But it wanted to know for you to find the sampling error. Now, it gave you the mean, 3.8 and 4.27. Now the difference between these is going to be your point estimate. Actually, just find the difference between these guys. It wasn't the greatest of questions, but you just had to find your sampling error, the difference between your population mean and your sample mean. It wasn't the greatest of questions, but it just kind of shows you can be off, and that you're usually off by your margin of error. Okay, 15. This probably starts to make a little bit more sense. Okay, we give you a confidence interval, and all you had to do was find your margin of error. So use your margin of error formula. When we do this, I'll give you the formulas. Oh, the only one that I need you to know is your regular z-score formula. That's the only one that I really, really need you to remember. The rest, I'll give you. And when you build the confidence interval, and we build it like this, that I expect you to remember that part. But I'll give you these in between formulas. I'll give you the margin of error. Today when we do the sample size, I'll give you the sampling one. I'll give you those, because they're a little tougher to remember. And really, you don't have to worry about remembering them. Most of you are going to end up using your calculator for this. And if you don't, you can always look up an equation real easily. God bless you. Could everybody find the margin of error given this? You need your ZC that corresponds to this. So the first thing you have to do is say, I have 90. I have 10 left over to share. So each one is 5%. So I do an inverse norm on 0.05. That's where this guy comes from. Now, keep it positive because your margin of error should be positive. However, when we put it in your plus or minus, it's going to work itself out anyway. We're going to take the opposite of it anyway. We're going to subtract it from your sample mean and add it to your sample mean. This guy had a confidence interval of 65. This was not on your table. So take 100 minus 65. You're left to share 35. Divide it in 2. Then don't forget to move 17.5. Don't forget to move your decimal. Keep your ZC positive and plug it into your formula. Some of you get a little confused on N, on your sample size from your test. Did I give you 16? No. Questions on finding your margin of error? If you're going to use your calculator for your confidence interval, you're just going to back out of your confidence interval to find your margin of error, which as soon as we get to that, I'll just show you again. Subtract the mean from the higher end, and you can find your margin of error without your formula. I gave you 19. Okay. So 19 had us make a confidence interval. It gave us your sample mean. Your confidence interval says plus or minus your sample mean plus or minus your margin of error. So I worked the whole thing out, plugged it in my formula, found this guy, 88, subtracted from 100, we're sharing 12, divided in half, each one is 6%. Find your ZC. Keep it positive. Your standard deviation over how many's in your sample. Find your margin of error. Then you just have to do this. 57.2 plus or minus 1.56. You can keep your margin of error in the same decimals as your mean, because that's the one you're adding and subtracting to. Your calculator, of course, rounds it to 3, 4, 5 decimals, depending on what it feels like doing. But you can keep it to your mean if you like. Subtract it and add it. Make your interval. You can write your interval like this, or you can write your interval like this. Do not leave it like this with the plus or minus in it. You can do this. You're saying that you're going to be 88% confident that your population mean It's going to fall between 55.64 and 58.76 of whatever this happens to be. Okay, that's why we write this. We're inferring about our population based on what we found out about our sample. Because we don't know anything about our population, so this is called an inference. We want our population mean to fall between those two numbers. And in this case, we want to be 88% confident. Now, this guy took the same information, but raised your confidence. And we said, if you want to be more confident, you need a little bit more wiggle room. So your margin of error is slightly larger. See your margin of error compared to this guy? It's slightly larger. So it makes this confidence interval wider. Not bigger, wider. The problem with a number line is all the numbers between each number is infinite. So you still always have an infinite amount of numbers in your number line between any two numbers. So your numbers don't get greater, your interval gets wider. So now, instead of, here's my 55.55, and here's my 58.85, as opposed to my 55.64 and my 58.76. It just expanded it a little bit. It gave me a little bit more wiggle room. If the more confident you want to be, the wider your interval gets. Not bigger, wider. Can you guys do this? Can you do this on your calculator? Okay, the interval ones are very nice on your calculator. Go to Stat and try it. Go to Stat. Go to Test. Now, all of your ends here are greater than 30. Your ends are greater than or equal to 30. So therefore, notice we're using a z-score. So you want to look for the word z interval. A z because my n is greater than or equal to 30. And an interval because I want to build the confidence interval. When you do this on your calculator, it just returns your confidence interval, like a little thing with parentheses.
Is the S the
Standard deviation. Yeah. You could either use, if you have your population one, or if you don't, you can use your sample one, because your sample size is greater than or equal to 30. Okay. So anybody do it and tell us what you got?
55.639. Wait, actually?
Yeah.
I'm on the other one. I was on that.
You're on this one?
Yeah.
Okay, so let's do this one. 55.639.
Yeah. And 58.761.
761. Thank you. Now, if you do this in your calculator, you just have to round. See it? We rounded here. They just go out a little bit further. Just round. If you're doing your confidence interval on your calculator, it doesn't give you a margin of error. So what you want to do is take your mean and subtract it off the larger one. So now I come up with 1.5. Well, if I kept on going, I would get it a little bit more exact. But I come up with my margin of error about 1.5. No, 1.5, because we rounded, they didn't. So you're going to figure out your margin of error by walking backwards. And you bypass all this work over here. You even bypass finding your ZC. Because your calculator says, just tell me what your confidence interval is. I'll take care of the rest. So it's a nice little calculator step. It's one of the ones that I probably use the most, the hypothesis testing and the confidence intervals. So much easier to throw it in your calculator. I think it even kind of helps understanding the problem a little bit more if you put it in your calculator. Can we do this? So what was the problem on Friday?
know how to do this on Friday.
How? How did you not know how to do this?
I know it now because you showed us, but I didn't know it.
Alright. 19 through 22. It was just matching these up. Oh, actually, we just did this one and oh, sorry, we just had to match these guys. I went through the whole thing, huh?
No.
Okay. Your confidence intervals, remember, the one with the highest confidence interval has to have the largest interval. It has to be the wider, not the largest, the widest interval. So go for the one that has the widest interval. This guy has to be the narrowest interval. And then you can match them up. And then you should figure out between 90 and 95. 95 is a little wider than 90. Could you match them up? I have to move this down a little bit. It kind of got stuck in here. Somewhere my thing got stuck in here. B. This one must be A. Were you able to do this? Based on your confidence interval, figure out which one was which? Okay. Next, 24. Again, find your margin of error. Calculate your margin of error. You have a table. And remember when I said add to your table so that you don't have to keep reinventing your wheel? There's a table on your notes that I gave you. It's not on your phone, Gunner. It's on your notes. But it would be in your notes, a little table, and I said add to that table when you find another confidence interval so that you don't have to keep repeating this part right here, finding this. So fill this in. You can absolutely do this on your calculator. Z interval. When you find your interval, take this and subtract your mean off the highest point. And you'll come up with your margin of error. That's acceptable. That's more than acceptable for me. 26, the same thing. I'm not sure if 99 was on your table. I think it's 98, but do one for 99. In 99, if 99% of your data is here, how much is left? 1%. If I divide this in half, I get 0.5 of a percent. So how do I write that in terms of a decimal? 0.005. Good. Bless you. That's the inverse norm you have to do. And actually, I don't know if you realized it, it's just this one and the one with the 1.645 is the one that they go out with 2575 and 1.645, they go out the extra decimal because it falls exactly in between two. The other ones aren't exact, but these guys are exact. Questions? What time does school end? Did we just wake you up? I'm sorry, Darian. None of these. 36. Okay, this was a good one. This had you construct a 90 and a 95% confidence interval. You need to learn how to pull your data out. In 36 randomly selected samples, this is your N. The mean, you're talking about your sample. So should this be a U or an X bar? X bar, this is coming from your sample. And a standard deviation from your sample of 6.7. We're greater than or equal to 30, so we're good. From this is the only information we need, and we need to know if it's a 90 and a 95 so that we can find this piece right here. Find this piece and this piece. That's the only thing that's changing from here to here. See it? Everything else is the same. And you're going to take your mean plus or minus your margin of error, and you're going to construct this. And you're going to find, to be more confident, I need a little bit more wiggle room. My margin of error is slightly bigger, which makes my confidence interval be slightly wider. Yes? How many of you can do this now? The rest of you can't? Talk to me. Tell me what bothers you. What's troubling on this guy? I have this one for homework, so let's do number 35. It says a random sample of 156 fields of durum wheat has a mean of 26.8 bushels per acre and a standard deviation of 8 bushels per acre. We need to find a 90 and a 95% confidence interval. So, how many is in your sample? 156. What is their sample mean?
26.8.
What is their sample standard deviation? 8.0? Okay, so we got all our information that we need. We need to construct a 90 and a 95% confidence interval.
Wait, how do you know it's 90?
Because that's what the direction said. The direction's right above it.
Oh, I was looking at the directions
As
for
the standard
31,
deviation.
36.
It's very simple. So, first thing we're going to do is find your ZC for a 90%. What is our ZC for a 90%? Look at your chart on your note page.
1.645.
Okay, 1.645. What's your ZC for a 95?
1.96.
God bless you. Well, there was a chart on your note page because we found this about 10 times already. We said this is 90. What's left over is 10. Yes, you do. What? Not. 100 minus 90 is what? Split this in half, so each one is 5%. How do I look this up? 0.05. That will give me 1.645. We have a chart, and I said, keep track on your chart, so for every homework problem, you don't have to reinvent the wheel. So, we know this. We know your formula for margin of error. And we know your formula for confidence interval. If you don't know this, you need to write all of this down. Margin of error, confidence interval. I'm right at the top, so it's not letting me go any higher on some of those things. Okay, so let's find your margin of error. 1.645 times the standard deviation, which is what? 8, divided by the square root of my sample, which is what? 156. So throw that in your calculator. Since our mean has one decimal, give me one decimal.
1.1.
1.1? Everybody agree with that? Okay? Everybody can find it? You don't need any extra parentheses in this. Put it in exactly the way you read it. 1.645 times 8 divided by square root of 156. Now, here's your formula. Our mean is 26.8 plus or minus 1.1. So we're taking 26.8 minus 1.1. That's the low end. We're taking 26.8 plus 1.1. That's the high end. This is my confidence interval. If you want to write it out the other way, you've got 25.7 is less than your population mean is less than 27.9. This tells me I'm going to be 90% confident that my population mean will fall between, for this wheat stuff, between 25.7 and 27.9. this is my inference about the population based on my sample. If I say I want it to be exactly 26.8, chances are I'm not going to hit that point. You told me it was better to hit an interval than it was to hit one exact point. Now, do the same for the 95. Take a minute, and I want you to walk through this same data. Okay, so, margin of error formula. 1.96. What else?
8 divided by square root of 6.
Ah, that did not change, right? The only thing that changed was this guy right here. This is the only difference when you change a confidence interval. You just want to be more confident. So the one that affects it is your z-score for that confidence interval. So what's your margin of error? 1.26, so we'll just give it 1.3. Now, notice that's where your increase is. X bar, so 26.8 plus or minus 1.3. 26.8 minus 1.3. So 25.5 is my lower end. And 26.8 plus 1.3. So yeah, we'll just round it. There's my upper end. Notice it's wider. If you don't see that it's wider, put it on the number line. You want to be 95% confident that your population mean for this week falls between 25.5 and 28.1. Okay?